Okay, so today we're going to start talking about kind of the next step beyond decimals, which is percents. To understand percents, it usually helps if you understand the word percent. Percent is actually two words. Per, if you think of miles per gallon, miles per hour, dollars per hour, it means for each or out of. And cent, which means 100. So if you look at that, let's say we have like 34%. That literally means 34 out of 100. It's a ratio or a fraction. And in fact, it's that easy to convert a percent into a fraction. It's just 34%, 34 over 100. Now as a fraction, we wouldn't leave it like this. What would we do with it? Both 34 and 100 can be divided by 2. So we can reduce that to 17/50ths. So let's look at a few examples of that. Let's take 65%. What's that going to become? 65 over 100, and we reduce it by 5, giving us 13/20ths. Or we might have 240%. What's that going to become? 240 over 100. Its percent is always out of 100. I'll show you. There's a spot where it does 1,000 does come into it, and I'll show you that in just a second. So 240 over 100, but you'll notice that is an improper fraction. So if I take that out, that's actually going to be 2 with 40 hundredths left over. If you think about it, 100% is the whole thing. That would be 1. So this is bigger than 100%, so it's going to be bigger than 1. So we have to have a whole number in there, a mixed number. So now the 2 isn't going to change, but the 40 over 100, both of those can be divided by 20 to give me 2/5. Can't forget the 2 whole objects there, so it's 2 2/5. Make sense? Okay, how about this one? Since Jason brought this up, 12.5%. What's that going to become? Well, 12.5 over 100, but here's where that 1,000 comes in. We don't like having decimal points within our fractions, so how are we going to get rid of it? Well, it's only one decimal place, so we're going to get rid of it by multiplying by 10. If it was 2 decimal places, we'd multiply by 100, and so on. So that becomes 125 over 1,000. And of course, that's going to reduce by, both of those can be reduced, divided by what? Actually, both can be divided by 125. It's 1/8. Very good. Or how about this one? 18 1/3%. What's that going to become? Well, 18 1/3 over 100. Now, we don't like having fractions within our fractions either. How are we going to get rid of that? Well, there's a couple of ways. We could just do 18 1/3 divided by 100, and that would come out. Or, since our biggest denominator, our common denominator, seems to be a 3, we can just multiply both the top and bottom of this fraction by 3. If we did 18 1/3 times 3, well, 18 1/3, 18 times 3 is 53, plus 1 is 55, or sorry, 18 times 3 is 54, plus 1 is 55/3. Times 3 over 1, the 3's cancel out, that's 55. 100 times 3 is 300, and both of those can be divided by 5. Give me 11/60ths. Make sense so far? Okay. Well, let's look at converting a percent into a decimal. Let's go back to that 34%. We said that was 34 over 100. To turn a fraction into a decimal, we're just going to divide. 34 divided by 100, which is 0.34. Since percent means out of 100, anytime we're going to convert a percent into a decimal, we're just going to divide by 100. And of course, the shortcut, anytime we divide by 100, we're just moving the decimal 2 spots to the left. So if I have 79%, that's going to become what as a decimal? Not everybody at once. As a decimal, 0.79, right? Dividing by 100. So you gotta move the decimal point 2 spots. To go from a percent to a decimal, 79% is 79 out of 100. If you divide that out, that's 0.79. So like, but it's 0.79 is what you want, not 79 over 100. You gave the fraction. I wanted the decimal.
Oh, you're trying to get the decimal from the percent?
Yeah.
Oh.
So 24%. Sorry if I wasn't clear there. 24% becomes 0.24. 119%. 2 spots, 1.19. It's over 100%, so it has to be bigger than 1, right? 7.4%. Careful. 0.074. Good. 280%. 2.8. Here's the one that I usually get people on. 1/4%. Careful. Because 1/4 is 0.25. That'd be 0.25%. Moving the decimal point 2 more spots gives you 0.0025. Think of it this way. When I deal with percents, I like to talk about benchmarks. One benchmark is 1%. 1%, of course, is 0.01. Yep, pretty much. Divide by 100. So 1/4% has to be smaller than 1%, so it better be smaller than 0.01. Now, if we're going to go the other direction, let's say we're going to go from a decimal back into a percent. So 0.73 is going to become what as a percent? Yeah, 73%. Because 0.73, the decimal means out of 1, and the percent means out of 100. So all we're doing is multiplying by 100, or moving the decimal point back 2 spots to the right. So if I have 0.09, that's going to become 9%. 2.4 is going to be 240%. Good. 0.035, 3.5%. We've got her down, it looks like. Changing a fraction back into a percent. Let's do one that we all know. 3/4, of course, is what percent? 75%. If we were confused, there are several things we could do. We could divide that out to get 0.75, and then, of course, just move the decimal point. That always works. Sometimes not the easiest way to go about it. Or we can do this. 3/4 can be thought of as 3 out of 4. A percent is always out of 100. We can set up a proportion like this. And to find the missing number here, we can cross multiply and divide. 3 times 100 is 300. Divided by 4 is 75. So it's 75 out of 100, or 75%. Like we might have 3/8. Well, what's that out of 100? We cross multiply and divide. What are we going to multiply? 3 times 100 is 300. Divided by 8 is 37.5. So it's 37.5 out of 100, or 37.5%. I'll let you guys try this one. How about 4/7? What percent is that? So it's going to be 4 times 100 is 400, divided by 7. You're right. 57.142857,143 approximately, right? So that's 57.14% if we're rounding to 2 decimal places. Yeah. If you want to keep going with it, I can keep going. It's 0.142857 repeating. So it's 142857, 142857, 142857 over and over again. What's that? No, that's rounded up. I rounded up because it should be 1428, so I rounded up to 143. I told you before, math is about patterns, and that's one of those patterns that once you see it, it's really easy. You start the calculation, you see the pattern pop up, so you just continue the pattern. There are a lot of those in math. Also, you got to remember, I've done this stuff pretty much every day of my life for close to 20 years now, for 19 years now. So you would hope I've seen some of the patterns. Yeah, math has been very good to me. When I was in college, I was an MPE major, math, physics, and engineering. Now, my 5th year of college, what's that? We'll pause this since Jay. Okay, so anyway, we can turn the fractions back into percents now. So now then, let's take a look at problem solving. A simple percent problem. Let's say we're asked blank is 70% of 90. So a simple little word phrase like that, filling in the missing number. When I work with percents, I always start with the percent. So we have 70%. So that's 70 over 100. No. Okay, yeah, so now we got to match up. We have two more numbers in here. We have the 90, but we also have the missing number. We have to figure out which one matches up with the 70 and which one matches up with the 100. Well, the first thing we have to do is we have to define what the 100 means. 100% is the whole thing. So in any problem dealing with percents, 100% stands for one of two things. Either it is the whole thing, the whole amount, or it's the beginning value, what you started with. So here, what matches up with the 70%? Well, if you just read it, the wording kind of gives it to you. Blank is 70%. So the missing number, the blank, matches up with the 70. The 90 goes down here. And now to find the missing number, what do? Cross multiply. 70 times 90 is 6,300. Divided by 100. So that's 63. Or we might have 30% of 60 is blank. This one looks quite a bit different, but it's really an identical type problem. We'll start with the percent. 30% is 30 out of 100. And again, we have two numbers. In this case, we have 60 and we have the missing number. So when we read this, again, the wording will help us figure out which one goes where. If we cover up one and just read it with the other number, like 30% of 60, well, that doesn't quite fit. If we cover up the 60 and read 30% is blank, well, that's what we're looking for. That's telling us that the blank matches up with the 30%. Now, another thing we can do is anytime we see the of, think of it as out of. 30% out of 60 implies the 60 has to go on bottom. So now we can cross multiply and divide. 30 times 60 is 1,800, and then divided by 100 is 18. What do you think? Not so bad? Let's look at some other types here. So we might have 28 is blank percent of 70. Now I said we always start with the percent, but here we don't have the percent. That doesn't change anything. We're still going to start with the percent. We're just going to do blank over 100. And now we have the two numbers. This time we have both of them. We have the 28 and the 70. We have to figure out which one matches up where. Yeah, now as I said, of 70, we can think of that as out of 70, which would indicate 70 is probably on the bottom. We also have 28 is blank percent, which implies the 28 matches up with that missing percent. And now we will cross multiply and divide. 100 times 28 is 2,800 divided by 70. Gives us 40. So that's 40%. Or we might have blank percent of 40 is 64. Looking at this one, where are we going to start? Blank over 100. Good. We're missing the percent. Careful. Yeah. Out of 40 implies 40 is on bottom. Blank is 64. 64 on top. Now, before we cross multiply and divide here, the top number is bigger than the bottom number, which would indicate what about our percent? Well, it's an improper fraction, but also the percent would be bigger than 100. The part is bigger than the whole thing here. So we cross multiply. 100 times 64 is 6,400. Divide by 40. You got it. 160. Good job, Jason. Well, it is. Are you using the percent key, or are you just cross multiplying and dividing? Right. That's one thing I will warn you. There's a percent key on those calculators. Be very, very careful with it. I don't use it because every function you do with it, the percent key behaves a little bit differently. I've found the percent key tends to make more mistakes. If you can set up the proportion, cross multiply and divide, it's so much easier than using the percent key. Let's do another form here. Let's say that we have 18 is 30% of blank. So where do we start? 30%, 30 out of 100. Now the 18 goes on top. Good. 18 is 30%. So we cross multiply and divide. 100 times 18 is 1800. Divided by 30 is 60. 18 is 30% of 60. Now as we look at these, there are other ways of doing it. Some of you may have been taught something called the rate method of percents. The rate method? What is that? Yeah. What the rate method is, and you may not have heard it called that, but the rate method is you turn the percent into a rate. For example, 70% becomes what? The rate. Oh, geez. Sorry. No, a rate is the decimal version of a percent. So 70% as a decimal would be 0.7. So to do this one, you would take 90 times 0.7, which gives you 63, which is the correct answer. And it almost looks like that's simpler. I mean, even this one here, 30% is 0.3, 60 times 0.3 is 18. Exactly. Let's go down to like this one, this last one we did. Here, if you turn 30 into a percent, it's 0.3. But it's not going to be 18 times 0.3. To do this one, it'd have to be 18 divided by 0.3. Or even up on this one. You don't have the percent, so you do 28 divided by 70 is 0.4, and then you have to move the decimal to make it 40%. So the problem with the rate method is it is quicker and faster, and it takes less paper. But you have to, each problem you do, you have to remember, do I move the decimal point first? Do I multiply? Do I divide? Do I move the decimal point when I'm done? The proportion method is what this is called. All you have to do is get the numbers in the right spot, and then the calculation is always cross, multiply, and divide. The proportion? Yeah, I think it's so much better. A lot of people try to teach this, especially if you get an algebra class, they try to teach that rate method. It can be confusing. And I even like the proportion because when you get into a word problem, let's say that, you currently make $12.50 per hour. And you're about to get an 8% raise. And you want to know how much is your raise. Well, you start with a percent. 8% is 8 over 100. The 8 represents your raise, correct? 100%, 100 always represents either the whole thing or the starting amount. In this case, the starting amount is the $12.50. So that tells you the $12.50 has to go on bottom. Cross, multiply, and divide. 8 times $12.50 divided by 100 is it 20 cents? Or is it, no, it's $1. You're right, sorry. $1. And you know it's set up right because the $1 represents the raise and the 8% represents the raise. So you know that's correct because they both represent the same thing. So when you're doing word problems, this proportion actually helps you set up itself to do it. It's almost easier to do the word problems than it is to do the simple percent problems. $1 raise? Yeah, that would be a huge raise anymore. I know a lot of people lucky if they get like 12 cents anymore.
I get a 25% raise after a year.
Yeah, but then after your second year, that's usually going from like a probationary status to a regular status or something like that, or it's not guaranteed every year, is it?
You go over 90 days when you leave probationary status.
Right. And most places are 90 days or 6 months, depending on.
Yeah, we don't get a raise. We just get a raise after a year.
But is that guaranteed every year or just the first year?
I don't know. Probably not guaranteed. I'm not going to be able to find out.
You hope not, right?
Still a couple
Oh yeah, we're at. Okay. Have you guys talked to Rick about recommendations if you need them?
Not yet.
Okay. If you need a second recommendation, then feel free to.
They all know I go to school here because I
Yeah.
in there.
Oh, sure.
So they're like, oh, you go here. I'm like, yeah.
If you need recommendations, let me know. By the way, page 79 and 80, 1 through 81, the odds. Page 84, 89, 1 through 53, the odds.